quadratic in nature. It might not look quadratic to you, but it does kind of resemble a quadratic. 6e to the 2x minus 16e to the x. Do what, Tina? I know it, I'm sorry. And I'm going to go ahead and move minus 6 over here, equals 0. It does resemble a quadratic equation because you look at the powers, and the first power is double the second power. Just like in a quadratic, if you have x squared plus 4x minus 5, that's to the first power. Anytime you see that this power is double this when it's similar to a quadratic equation, like x to the fourth plus 3x squared, that's quadratic in nature. So what we're going to try to do, we're going to try to factor this like a quadratic equation. So watch very closely. We ask what adds to give us negative 16, and what multiplies to give us negative 36. What would that be? Negative 18 and 2. What do we use negative 18 and 2 to do? You split it. 6e to the 2x minus 18e to the x plus 2e to the x minus 6 equals 0. This is going to be fun. Group it and watch really close. Factor out a 6, and also factor out an e to the x power. Think about your rules for exponents. If I multiplied e to the x times e to the x, that's e to the 2x power, because you add exponents, correct? X and x is 2x. So 6e to the x times what gives you 6e to the 2x? E to the x. Minus 3. That's the easy part. You got the hard part, that's the easy part. Plus, what are you factoring out of the second one? 2 times e to the x minus 3. Nearly done. E to the x minus 3 times 6e to the x plus 2 equals 0. Any questions so far? Need some extra room. Okay, this times this is 0. This is your zero product property. If two things are multiplying to give you a 0, one or the other has to be 0. So what you're going to do now, you're going to say, okay, first off, e to the x minus 3 could be 0. And let's solve that first. Let's just do one at a time. We're doing this part first. E to the x minus 3 is 0. How do you solve that? E to the x equals 3. What do you do now? There you go. Rewrite it. We don't know what else to do, so rewrite it as log base e, which is of 3 equals x. I don't care if you're leaving it like that. X is the natural log of 3. There's your first answer. That's a number. That's one thing. That's one solution. That is one answer. Yes, x is that. If you plugged in the natural log of 3 for x, then it would come out equal. And again, think about, Christina was talking about the e's. She don't like e's. Think about e as just a number. E is 2.718. So x equals natural log of 3. If you want to actually find an answer there, that is a number. The second answer, you're going to say, okay, 6e to the x plus 2 could also be equal to 0. Move the 2 over, divide by 6. Let's do both of those in the same step. Negative 2 divided by 6. Natural log, negative 1/3 equals x. What are you going to put there? You can't do that. So there's one solution, natural log of 3. Can't take the log of a negative. That's the reason we could dump that second solution. Okay, on the next one. We're asked to solve this for x, to try to get x by itself. Watch the steps, do the best you can. This is by far the toughest problem that you're going to have on your homework. Let me move this over because we're probably going to need plenty of room. First thing we're trying to do is, again, to get x by itself. What I'm going to do, I'm going to do something with e to the negative x. I can make that a positive, but this is be a good time to share something with you. I can't take it down here because of this minus sign. If this stuff was being multiplied together, yeah, sure, just bring it to the bottom. So since you got this minus this, you can't bring it to the bottom in this case because, well, number one, what happens to the minus sign? That's one problem. So what I'm going to do, I'm going to rewrite it like this: e to the x minus 1 over e to the x. I can do that. I can make it its own little personal fraction, and I can bring it to the bottom of that. Okay, now, I'm going to try to get rid of any fractions that I may have, like fractions over fractions, and here's how I'm going to do that. I can get rid of this 1 over e to the x by taking top and bottom of this. And same thing as taking 3/4 and multiplying top and bottom by 2. That's legal. It's 6/8. It's still the same thing. So I'm going to take this first fraction. I'm going to multiply top and bottom of that first fraction by e to the x. That's a common denominator. By multiplying by a common denominator, I get rid of a fraction. So I've got to multiply the top and the bottom by e to the x, which isn't as bad as it sounds. E to the x times e to the x is e to the 2x. Minus e to the x times 1 over e to the x. What happens there? The e to the x cross cancel and leave me with just 1 over 2e to the x. Any questions so far? Equals t still. From where to where? From this step to this step. Multiply the top by e to the x, multiply the bottom by e to the x. You're okay where the 2e to the x came from, right? But e to the x times e to the x, add exponents. Same base. Yeah, I'm just getting rid of my fractions up top. Same base, you add the exponents. X and x is 2x. That's where this e to the 2x came from. E to the x times 1 over e to the x. Using cross canceling, those just cancel out, leaves you with 1. So that's where this 1 came from. Try to hang with me till the end, and then I'll come back and get any questions that you may have. Okay, next up, we're going to get rid of our entire fraction. Okay, we can move this 2e to the x over to the other side, so now we have e to the 2x minus 1 equals 2t e to the x. Right? I'm going to move the 2t e to the x over here, and it's going to be a quadratic. So you have e to the 2x minus 2t e to the x minus 1 equals 0. Okay, next up, we're going to complete the square. We're going to complete the square. No problem, this was easy. So we're going to move our 1 over. So we got e to the 2x minus 2t e to the x equals 1. Half the middle squared, add it to both sides. So half the middle, square it, which that's going to be 1t. We're going to add t squared to both sides. With me? Plus t squared. Okay, think about it. Think about it. X squared plus 6x, you never add the x to both sides. You're halving the 6 and squaring it, and that's what you're adding to both sides. The coefficient, when you're completing the square, it's just the coefficient. It's just the stuff in front of the whatever you get by itself. So now, we can factor the left side. The left side is going to factor into, if this had been x squared, it'd be factored into x, right? So it's going to factor into e to the x. Can anybody tell me what the rest of it's going to be? Minus 1t squared equals 1 plus t squared. Y'all just stay with me. Just keep watching. Because now it's the easy part. Now it's the easy part. Because we have a single x. Get rid of the square root. How? And don't forget to plus and minus in front of it. 1 plus t squared. Next step. So you have e to the x equals t plus and minus the square root of 1 plus t squared. Nearly there. We've still got to get x by itself. To get x by itself, change forms. Good job. The natural, because you got log base e of this stuff equals x. So log base e is the natural log of t plus and minus square root of 1 plus t squared equals x. Okay, next one's asking us to do the exact same thing, trying to get x by itself, and we're going to use the same method that I used on the previous problem. Go ahead. multiplying by the conjugates? You could try it. It might do something, but the only thing, you multiply top and bottom by conjugate, it might do something there. Might get that off the bottom. I don't know. There's a good possibility. So e to the x minus 1 over e to the x over e to the x plus 1 over e to the x. Even though you might not know how to do the entire problem, little pieces like that would be valuable information. Knowing if you have a negative exponent, it trains your brain. Knowing if you have a negative exponent, you can make that as 1 over. It kind of goes back and reviews you a little bit. I'm going to do the exact same thing. I'm going to try to get rid of these little fractions inside the big fractions by multiplying top and bottom by e to the x. So on top you're going to have e to the 2x minus 1. On bottom you're going to have e to the 2x plus 1. Okay, the next step, I'm moving my e to the 2x plus 1 over here, so I now have e to the 2x minus 1 equals, and we're going to have to distribute that t as we move it, te to the 2x plus t. Any questions? Moving the stuff to the left side now. This one might not be as hard as the first one. I don't think it is. I'm going to move my te to the 2x to the left side. I'm going to move my minus 1 to the right side. So you have e to the 2x minus te to the 2x equals t plus 1. Let me explain why I'm doing what I'm doing. Your main thing here is to try whatever you can do to get just one x. Just a plain x instead of having x's everywhere. With moving them all to the same side, you got e to the 2x, e to the 2x, you can actually factor now. Does that make sense? You can factor out an e to the 2x because when you do you notice you're down to 1x? So e to the 2x factored out of that becomes what inside? 1 minus t. Right? Move the 1 minus t over here because now our main goal is just getting x by itself. So let's move 1 minus t over. We have e to the 2x equals t plus 1 over 1 minus t. And I don't know, I've got this odd inkling just to want to change that to 1 plus t on top because you got 1 minus t on bottom. You can do that if you're OCD like I am. But e to the 2x equals this stuff. What do you do next? We've got to try to get x by itself. Natural log change forms. Yeah. Yeah, that's what I'm saying. Yeah. You can't cross out because you can only cross out whenever you have multiplication and division. Or excuse me, multiplication. Can't cross out pluses. Okay? That's the only time you can cross out the whole thing. But you can't cross out pieces. So let's change it to natural log stuff. So you got the natural log of... Yeah, let's make it look better. I like 1 plus t over 1 minus t equals 2x. Nearly done. How do you get the 2 over here? You divide by 2. Would it upset anybody if I multiply by a half instead of dividing by 2? There's a reason for that. A division by 2, I could divide the whole side by 2. That's the same thing as taking half of it. The reason I want to do it like that is because it makes it look better. Because now I can move that up top. Power rule, 1/2 times something, that's the natural log of 1 plus t over 1 minus t to the 1/2 power, which I can write as the natural log of what? Something to a 1/2 power. The square root. X equals the natural log of the square root of 1 plus t over 1 minus t.